This is the final part of the 5-part series on the net ionic equation. In this video, we're going to write the total and net ionic equation where only the reactants are given and nothing else. If you're new to writing ionic equations, I recommend you start with the first 2 videos in this series. Let's take a look at our question. We're given the reactants and that's about it. I consider this pretty difficult because we don't have the products and we don't know the physical states. So since that's the case, the first thing we need to know is to predict the products. But before we can do that, we need to know what kind of reactions these reactants will undergo. So generally, there are 3 types of reactions involving net ionic equation. The first is single replacement reaction, where A and B will swap place. That's known as a single replacement reaction. Whereas the second type is a double replacement, where AB and CD will both swap places. So because 2 terms are involved, that's why they're called the double replacement reaction. And the final one is neutralization, where you have acid plus base, Ha plus BOH, giving us salt, which is Ba, and water, H2O. So let's take a look at our given question. We have HNO3 plus KOH. It looks like we have a Ha plus BOH. So looks like we have a neutralization reaction. If you identified this as a double replacement reaction, you'll be fine as well, since you'll get the same products eventually. If you don't believe me, give it a try, and we'll double confirm our work at the end. So A is actually NO3 minus, and B is actually K plus. Now that we've identified our A and B, let's go ahead and find the products, Ba and H2O. Ba is going to be KNO3. You want to be careful when you're writing out the formula for ionic compound. Make sure you pay attention to the charges. So in this case, this is a simple clear-cut KNO3. But sometimes you have different charges and the formula is going to come out differently. Now that we figure out the products, it's time to move on to the second step, which is identify the physical states using solubility rules. If you need a refresher on how to determine the solubility of the compounds, I'll link the video here. So looks like we have aqueous for the acid, base and salt, and liquid for water. Moving on to step 3, we need to make sure that the equation is balanced. In our case, this equation is already balanced, so we're good to go. Now we move on to the 4th step, which is ionize the AQ terms. That means we need to break the terms that have AQ states into ions. Now keep in mind that we only do that for AQ terms. We don't touch solid, liquid, or gas. We just leave them be. Let's start with the first term, which is HNO3. It's made up of H plus and NO3 minus. And moving on to our second term, KOH is going to break into K plus and OH minus. And our product, KNO3, is going to become K plus and NO3 minus. And water, because that is liquid, we're just going to write it out as H2O. So what we've done right now is we have written out the total ionic equation. So the next step that we're going to have to do is to cancel out the spectator ions, which are ions that are present on both sides of the equation. So if we look closely, we have NO3 minus on both sides. So we're going to cross it out. And then if you notice, we also have K plus on both sides. So we're going to cross it out as well. So what we're going to do is we are going to rewrite the equation, and then we will get H plus aqueous plus OH minus aqueous as well, giving us H2O liquid. That is actually the net ionic equation. Now, before we call it done, let's just double check our work real quick. We need to have the same number of atoms on both sides of the equation. We also need to make sure that our charges are the same on both sides of the equation. So it looks like we have 2H and 1O on both sides, so we're good. For the charges on the left-hand side, we have +1 for H plus, -1 for OH minus. So +1 minus 1, that's going to equal 0. So the total charge on the left-hand side is 0, and the total charge on the right-hand side is 0 as well. That means we did it. So there we have it. We've managed to write the total and net ionic equations in 5 simple steps. When the question only gives us the reactants, we need to predict the products after figuring out what type of reaction is involved. And then after that, we need to figure out the physical states using solubility rules. Then we balance the entire equation. And then after that, we look for the AQ terms and we split them up. And that will give us the total ionic equation. Make sure you don't touch the solid, liquid, or gas terms. And once you have written out your total ionic equation, you cancel out the ions that appear on both sides of the equation and then rewrite it and that will give us the net ionic equation. If you're looking to practice on writing net ionic equation for other types of reactions, look for part 3 and part 4 of this series. I hope the video was helpful. Do subscribe, and thanks for watching.